find contractors specializing in solar installations in New England, you can explore several options. Becca Solar operates in New Hampshire, Maine, Massachusetts, and Vermont. Origo Solar Systems serves Connecticut, Massachusetts, and Rhode Island. CED GreenTech is located in Massachusetts and New Hampshire. Greenlancer Energy covers Connecticut, Maine, Massachusetts, New Hampshire, and Rhode Island. WeVision Energy has a presence in Connecticut, Maine, Massachusetts, New Hampshire, Rhode Island, and Vermont. SunPower by Suncommon operates in Massachusetts, Connecticut, and New York. For apprenticeship inquiries, consider the North American Board of Certified Energy Practitioners, also known as NABCEP, and the Solar Energy Industries Association, also known as SEIA. Your local utility company might also offer apprenticeship programs for solar installers. Additional resources include the Solar Training Network and the New England Clean Energy Council. Local trade schools and community colleges may offer solar installation courses and programs. When looking for an apprenticeship, reach out to the contractors listed directly. Attend industry events and conferences. Network with solar professionals on LinkedIn and other online platforms. Consider volunteering with solar energy organizations. Be persistent and don't give up if you don't get an apprenticeship immediately. Solar energy is harnessed through photovoltaic, also known as PV, cells which convert sunlight directly into electricity. These cells are typically made from silicon, a semiconductor material. When sunlight strikes the PV cell, photons, or particles of light, knock electrons loose from the silicon atoms. These electrons flow through an electrical circuit, creating electricity. Multiple PV cells are combined to form a solar panel, and multiple panels are connected to form a solar array. Solar arrays can be installed on rooftops, in open fields, or integrated into building materials. The electricity generated by solar panels can be used to power homes, businesses, and even entire communities. Solar energy systems typically include several key components. These include the solar panels themselves, which capture sunlight and convert it into direct current, also known as DC electricity. An inverter converts the DC electricity into alternating current, also known as AC electricity, which is the standard form of electricity used in most homes and businesses. A mounting system secures the solar panels to the roof or ground. A monitoring system tracks the performance of the solar panels and the overall system. Some solar energy systems also include batteries, which store excess electricity for later use. The size of a solar energy system is typically measured in kilowatts, also known as kW. A 1 kW system can generate about 1200 kilowatt-hours, also known as kWh, of electricity per year, depending on the location and the amount of sunlight. The cost of a solar energy system varies depending on the size of the system, the type of equipment used, and the installation costs. However, the cost of solar energy has decreased significantly in recent years, making it more affordable for homeowners and businesses. There are several types of solar panels available, including monocrystalline, polycrystalline, and thin film panels. Monocrystalline panels are made from a single crystal of silicon and are the most efficient type of solar panel. Polycrystalline panels are made from multiple crystals of silicon and are less efficient than monocrystalline panels but also less expensive. Thin film panels are made from a thin layer of semiconductor material and are the least efficient type of solar panel but also the most flexible and lightweight. Solar energy is a clean and renewable source of energy that can help reduce greenhouse gas emissions and combat climate change. It is also a reliable and cost-effective source of energy that can save homeowners and businesses money on their electricity bills. The installation of solar panels requires careful planning and execution to ensure the system operates safely and efficiently. Firstly, a site assessment is conducted to determine the best location for the solar panels, taking into account factors such as sunlight exposure, roof orientation, and shading from trees or other buildings. Secondly, the system is designed to meet the energy needs of the home or business, taking into account factors such as energy consumption, panel efficiency, and inverter size. Thirdly, the necessary permits are obtained from local authorities. Fourthly, the mounting system is installed on the roof or ground. Fifthly, the solar panels are installed on the mounting system. Sixthly, the inverter is installed and connected to the solar panels. Seventhly, the system is connected to the electrical grid. Finally, the system is tested and commissioned to ensure it is operating properly. The National Electrical Code, also known as NEC, provides specific guidelines for the safe installation of solar energy systems. These guidelines cover topics such as wiring methods, grounding, overcurrent protection, and disconnect means. It is important to follow the NEC guidelines carefully to ensure the solar energy system is installed safely and complies with local regulations. For example, NEC Section 690.41 requires that all exposed non-current carrying metal parts of a solar energy system be grounded. This helps to prevent electric shock hazards. NEC Section 690.7 specifies the maximum voltage allowed in a solar energy system. This is important to prevent equipment damage and fire hazards. NEC Section 690.9 requires that overcurrent protection be provided for all solar energy circuits. This protects the system from damage caused by excessive current flow. NEC Section 690.13 requires that a disconnect means be provided to isolate the solar energy system from the electrical grid. This allows for safe maintenance and repair of the system. The performance of a solar energy system can be affected by several factors, including shading, temperature, and panel orientation. Shading can significantly reduce the amount of sunlight that reaches the solar panels, reducing their output. High temperatures can also reduce the efficiency of solar panels. The orientation of the solar panels affects the amount of sunlight they receive throughout the day. Solar panels should be oriented towards the south in the northern hemisphere to maximize sunlight exposure. Regular maintenance is important to ensure the solar energy system operates efficiently and reliably. This includes cleaning the solar panels to remove dirt and debris, inspecting the wiring and connections for damage, and monitoring the performance of the system. Solar panels should be cleaned regularly, especially in areas with high levels of dust or pollution. The wiring and connections should be inspected periodically for signs of corrosion or damage. The performance of the system should be monitored to detect any problems early on. Solar energy systems can last for many years with proper maintenance. Most solar panels come with a 25-year warranty, but they can often last much longer. Inverters typically have a shorter lifespan of about 10 to 15 years and may need to be replaced during the lifetime of the solar energy system. Batteries, if included in the system, also have a limited lifespan and will need to be replaced periodically. The cost of electricity from solar energy has decreased significantly in recent years, making it competitive with traditional sources of electricity such as coal and natural gas. The levelized cost of energy, also known as ELCO, is a measure of the total cost of electricity from a particular source over its lifetime. The ELCO of solar energy has decreased dramatically in recent years, making it one of the most cost-effective sources of electricity in many parts of the world. In some areas, solar energy is now cheaper than electricity from the grid, a phenomenon known as grid parity. Grid parity is achieved when the cost of electricity from solar energy is equal to or less than the cost of electricity from the grid. As the cost of solar energy continues to decline, it is expected that grid parity will be achieved in more and more areas. Solar energy is a key technology for achieving a sustainable energy future. It can help reduce greenhouse gas emissions, combat climate change, and create a cleaner and more reliable energy system. Solar energy is also a source of economic development, creating jobs in manufacturing, installation, and maintenance. As the world transitions to a clean energy economy, solar energy will play an increasingly important role. The efficiency of solar panels is a critical factor in determining the amount of electricity they can generate. Panel efficiency is defined as the percentage of sunlight that is converted into electricity. Monocrystalline solar panels typically have efficiencies of 17% to 22%, while polycrystalline panels have efficiencies of 15% to 17%. Thin film panels have lower efficiencies, typically ranging from 10% to 13%. Higher efficiency solar panels can generate more electricity from the same amount of sunlight, reducing the number of panels needed for a given application. Inverter technology is also constantly evolving, with new inverters offering higher efficiencies and more advanced features. String inverters are the most common type of inverter used in residential solar energy systems. They connect all the solar panels in a string to a single inverter. Microinverters are installed on each individual solar panel. This allows each panel to operate independently, maximizing energy production. Power optimizers are similar to microinverters, but they do not convert DC electricity to AC electricity at the panel level. Instead, they optimize the DC electricity before it is sent to a central inverter. Battery storage is becoming increasingly popular in solar energy systems. Batteries can store excess electricity generated by the solar panels for later use, such as during periods of peak demand or during power outages. Lithium-ion batteries are the most common type of battery used in solar energy systems. They offer high energy density, long lifespan, and relatively low cost. Battery storage can increase the self-consumption of solar energy, reducing reliance on the grid. It can also provide backup power during power outages, improving energy security. Smart inverters are becoming increasingly important in grid-connected solar energy systems. Smart inverters can communicate with the grid, providing information about the solar energy system's output and status. They can also respond to grid signals, such as voltage and frequency fluctuations, to help maintain grid stability. Smart inverters can also provide advanced functions such as voltage and frequency ride-through, which allows the solar energy system to continue operating during grid disturbances. The growth of solar energy is being driven by a number of factors, including declining costs, government incentives, and increasing environmental awareness. The cost of solar energy has decreased dramatically in recent years, making it more affordable for homeowners and businesses. Government incentives, such as tax credits and rebates, are also helping to drive the growth of solar energy. Increasing environmental awareness is also motivating people to switch to solar energy as a way to reduce their carbon footprint. The future of solar energy is bright. As the cost of solar energy continues to decline and technology continues to improve, solar energy is expected to play an increasingly important role in the world's energy mix. Solar energy is a key technology for achieving a sustainable energy future.